Good evening, everybody. Today we're going to be doing practice and problem solving for solving problems with rational numbers. So let's get started. I've got number 7. Suppose there is a 1.1 drop in temperature for every 1,000 feet that the airplane climbs into the sky. If the temperature on the ground is 59.7, what will be the temperature at the altitude of 11,000? Well, since we're at 11,000 feet and we got 1.1 drop for every 1,000, we're going to have to take 11 and multiply it to 1.1. If we do that, we can see that we have 1 here, put a 0 there, 1 here, and that's going to give us 121. And then we have to move that decimal over 1, so it'd be 12.1. Now we have to subtract that from 59.7. And when we do that, we see that because I said the temperature on the ground was this amount, since it's being subtracted by this amount every 11,000, we subtract 12.1, and that's going to give us, see, a 6, a 7, and a 4, 47.6 degrees Fahrenheit. Okay, and that is our answer for number 7. Let's move on. Number 9, a certain plant grows 1 1/6 inch every week. How long will it take the plant to grow 6 1/6 inches? Well, to do this, we're going to have to divide 6 1/6 inch by, let's see, it grows this much every week, so we have to divide it by 1 1/6. Let's see, yeah, to grow this amount, we have to divide it by there, so let's use our KFC method. Keep, flip, change. And if we do that, first we have to turn these into improper fractions. 6 times 6 is 36 plus 7 makes, or it's plus 1 makes 37. And that's 37 over 6. And we'll be dividing that by 6 plus times 1 is 6, and plus 1 would be 7 over 6. And now we use the keep, change, flip. This will turn into 37 over 6 times, remember we're changing from division to multiplication. We keep the first number the same, we change from division to multiplication, and now we flip the second number, so this would be 6 over 7. And now we can use a butterfly method to get rid of our 6 on each side and turn it to 1. And this is going to leave us with 37 times 1, which is 37, and 1 times 7, which is 7. Okay, so how much is it going to grow? Let's see. We have to see how many times 7 goes into 37. So this is 37 divided by 7. We know that 7 times 5 is 35, with a remainder of 2. So in essence, our answer is going to be 5 and 2 over 7. Luckily, we got 7 on the bottom here, and there are 7 days in a week. So this is really going to be 5 weeks and 2 days. All right, let's go ahead and move on to number 11. Brianna works at a customer service as a customer service representative. She knows that the amount of her yearly bonus is $155, but $2.50 is taken away for each customer complaint about her during the year. What is her bonus if there is 12 complaints about her in the year? Well, we have to take 12 and multiply it to $2.50. That will tell us how much she's going to be money is going to be removed from her during the year for her complaints. Luckily, this is going to be pretty easy because 250 times 2 is 500. And then 1 times 250 is, of course, 250. And now we have 0, 0, 0, carry the 1, which will make 3. And now we have to move our decimal over 2 spaces because it was there were 2 spaces here where our decimal is. Right there, 1, 2. And so when we move it over twice, we get 30. So that means there'll be $30 removed for complaints. So if we take 155 and we minus 30 from it, that's going to leave us with $125. So she will receive a $125 bonus. Next one, number 13, says that Marcelo played a carnival game at the interstate fairs 6 times. He spent 3 tokens to play each game, and he won 7 tokens each game. Write 2 different expressions that can be used to find the total profit in tokens that Marcelo made. Well, one, we could say that since there were 6 games, and let's see, he spent 3 tokens, so that's going to be -3, but he won 7 tokens. So this could be 7 minus 3. That could be one expression. The next one could just simply be, let's see, 6 times 7. And we could add that to 6 times -3. Some of you might be wondering if these equal the same thing. Let's check that out. Well, first of all, 7 minus 3 is 4. So this will now be 6 times 4. And that equals 24. Over here, we got 6 times 7, which is 42. We're going to add that to a -18, because 6 times -3 is -18. Well, now that's really 42 minus 18. And that's going to equal 24. And look at that, we got the same amount. All right, let's go to number 15. Number 15 says, and I'm going to need a little bit of room here, so I'm going to add a little bit to my page. There we go. It says here that the table shows the relationship between the hedgehog's change in weight and the number of days of hibernation, okay? These are the days of hibernation. These are the days of weight. What number represents a change in weight for each day of hibernation? For each day, so we'd have to take this number and divide it by this number to get 1 day. What 1 day is. So let's see. If I did that, I'd have 0.24, and I'd be dividing it by 8. Well, that's pretty simple. Point over here, and that'd be 0.03. So 0.03 ounces. 0.03, and that, since he's losing weight, right, weight change, be negative 0.03. Since it's ounces, it'll be ounces, OZ. Now we have to make sure that every one of these here comes up to the same one before we can make that claim. So let's make sure that every one of them comes up to 0.03. First of all, we've got 0.84, 0.84 divided by 28. That gives us 0.03. That checks out good. Next, we got 2.25 divided by 75. That also gives us 0.03. And the last one is 2.79 divided by 93. That also gives us 0.03, so we can make that claim just fine. Now that we know that, let's go on to B. What number represents the change in weight in ounces for the hedgehog in 115 days? Well, that's really easy. We could just take 115 days and multiply it to 0.03. If we do that, well, that's going to be 15, carry the 1. That's going to be 3, then 4. Then that's going to be 3. We have to move our decimal place 2 spots. So that's going to make 3.45 ounces. And again, we're talking about negative numbers. So it'd be negative 3.45. Well, that's all of them that I had to do tonight. Good luck with yours, and see you tomorrow.